As what you said before, we aim to explore how modification of hyperparameters and layers could affect transformers performance metrics in a variety of NLP texts to answer two questions. First one is that the modification to our transformers result in significant improvement on other NLP texts that have not been covered by the paper written by Naran et al. In 2021. To answer this question, we introduced the natural language inference text in discovering this puzzle. And the second question is that could we further push the performance boundary of transformer by capturing the local and global dependencies? And our method is we exchange the feed-forward neural network in a sublayer in the transformer with a convolutional neural network sublayer. The motivation here is that a vanilla transformer does not take into account the relative distance among words, and that is substitution. And that substitution with convolution layer might work as a remedy to such as drawbacks by concentrating solely on local dependencies. However, global dependency are still out our interest, and that we are like to take that into our account. As a matter of fact, instead of embracing fixed middle size given by the CNN structure, we're looking at a whole sentence. We propose distance mac and intention and replacing CNN structure with diffusion gate. Distance mac. Well, distance mac in its meaning is max multi-head attention rather than the standard attention. In addition to the simple distance mac inspired by IM and Cho in 2017, we also introduced the forward and backward messages by Shen et al. In 2018. In particular, the word distances are weighted and well considered in the modified transformer, allowing the model to underscore the local dependency without undermining the global dependencies. And the diffusion gate resembles the gate structure of LST and is placed right after the max multi-head attention. The purpose of this is to encode long-range dependency from both the forward and backward direction as a complement structure toward the forward and backward mask. And the experiment setting is about about using the pre-trained word embedding without fine-tuning BLOF A40B300D1. And the optimizer we use is Atom, and we implement the whole code in PyTorch. Result and discussions. For natural language inference, the result shows that when we use torch and the linear as a feed-forward layer, the existence of distance mac does not influence testing accuracy. If we use torch and column 1D instead, its performance with distance mac is slightly worse than that without distance mac. The results show that even though column 1D and linear are theoretically the same, there are actually some minor difference in practice. Without distance mac, the result of column 1D and linear are close enough. For example, only 0.1%. When we include a distance mac, the difference becomes negative 0.4%. From machine translation tests, the result shows that when we use linear layers, having a distance mac is better than without a distance mac. When we use 1 gram, this difference reached 2.41%. Even with the increase of the gram size, the difference decreased, but it's still above 1%. However, using column 1D instead, two models are tied up. It doesn't show significant advantages among models comparing linear and column 1D. No matter whether we have distance mac or not, column 1D is better than linear. Discussions. In machine translation task, distance max shows its advantage, which has roughly 2.4% difference in 1 gram. However, the NLI test does not show huge advantage using distance max. Even column 1D without distance max has highest accuracy. And the NLI is insignificant using a distance max, and this is highly due to its majority sentences are short. And for machine translation tests, there's an evaluation metric problem. The blue score cannot semantically capture the entire meaning of the translated sentence. Conclusion. We analyze the significance of word distance under two different texts, NLI and machine translation from English to Chinese. And secondly, we use the distance max to capture the local dependency without losing the ability to capture the global dependency. And thirdly, we researched the real-world difference between